solving by factorizing shouldn't be something that's new to us, right? But hopefully I can, like with the index laws and those exponential equations, hopefully I can take this idea that we've been looking at before and see how we can extend that. Before we look at that, right, what's our kind of concept here? We've looked at factorizing and we've looked at solving. Now we're putting them together, I get solving by factorizing, right? That's what we're trying to do. We're trying to apply these skills and concepts together. With solving by factorizing, there's a very key idea that we look at. If I have any two things multiplied together and they equal to 0, right, there is an identity that we can use. There's a lot of different terms for it. They call it the Null factor theorem or the product theorem or things like that. But we can know something about A and B. What do we know about A and B? Right, either A equals to 0 or B equals to 0. So anytime we have an equation, this idea of 0 is very powerful, okay? I want to find what are my A's and B's. But like you saw with that exponential equation, there's a lot of different approaches to do this. N squared minus 25 equals to 0. Can someone suggest one way I could try and solve this? Joel.
Plus 25 to both sides.
Okay, that is one way. Balancing equations. We add 25 to both sides. And then what do? I take the square root of both sides because I'm looking for n. I remember, what do I do when I square root both sides? I take the positive and minus cases, right? So plus or minus 5, and those are my answers. Can anyone think of a different way to do it? Callum. Difference of 2 squares. So n squared minus 25, hopefully you're starting to recognize that now. That's actually a difference of 2 squared. So I can write that as n plus 5 and minus 5. And like I established up here, okay, if I have two things multiplied together and they both equal to 0, either this is 0 or this is 0, and you can solve those equations separately. You'll get n equals to 5 or negative 5 there. Okay. So two ways of approaching the same one, whichever makes more sense to you. Why is the factorized form so powerful? Right? It's because if it's in the factorized form, you actually don't need to do any additional work. You can actually identify the solutions for here. You're essentially saying, okay, I want what's inside this to be equal to 0. So that would mean that x would equal to 3 here, or whatever the value of x here that makes it equal to 0, it would be negative 5. Okay. So that factorized form is what we want because it allows me to identify the solutions without even having to think about it. I can just look at it. This is not factorized. How can I get it factorized? PSF. Okay. Mick, can you PSF this for me? Sure. All right. Yep. Negative 5, yep. And what are my factors? 2 and 3. Do those add to negative 5? Minus, good. Okay, so I've got negative 2, negative 3. So putting that all together, right, those are my factors. Okay, and those is going to go in my two brackets because we established that factorizing is looking for what's in common, or we're trying to put things into brackets. So those are going to be my factors there, m minus 2, m minus 3. So what are my solutions? Again, I just look at my brackets there and I see, oh, okay, I want this to be equal to 0. So I should really do it like this. That's makes sense. So I factorize it. Now I'm identifying the solutions. So I either have m equals to 2 or 3. Any questions about that? Yeah? Sorry? Sure. Thank you, Matt.